This is SpaceTime, Series 28, Episode 141, for broadcast on the 1st of December 2025. Coming up on SpaceTime, have scientists finally detected dark matter? The European Space Agency's CHEOPS spacecraft about to reach another milestone. And a major disaster at the Baikonur Cosmodrome as the Soyuz MS-28 spacecraft blasts off for the International Space Station. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Well, after nearly 100 years, astronomers may finally have detected that mysterious substance known as dark matter. A report in the Journal of Cosmology and Astroparticle Physics claims scientists detected the elusive substance through the emission of gamma rays generated as dark matter particles collide and annihilate. The observations were made using NASA's Fermi Gamma-Ray Space Telescope. Back in the early 1930s, it was Swiss astronomer Fritz Zwicky who observed that galaxies in space were moving faster than what their masses should allow. And that prompted him to infer the presence of some invisible scaffolding, a sort of dark matter, if you will, which was holding the galaxies together. Now, nearly a century later, astronomers may finally, for the first time, have provided direct evidence for dark matter's existence, allowing the invisible substance to be seen. Dark matter has remained largely a mystery ever since it was first proposed. Scientists have only ever been able to indirectly observe dark matter through its effects on normal, that is, observable matter, such as its ability to generate enough gravitational force to hold galaxies together. If their calculations are correct, 85% of the universe's total mass is made up of dark matter. Only 15% of the mass of the cosmos is made up of normal, observable, what we call baryonic matter, the stuff that makes up stars and planets and trees and dogs and cats and people. The reason dark matter can't be observed directly is because the particles that make up dark matter don't interact with the electromagnetic force, meaning dark matter doesn't absorb, reflect, or emit light. Of course, hypotheses abound, but many researchers think dark matter is made up of something called weakly interacting massive particles, or WIMPs. These are heavier than protons, but they only weakly, if at all, interact with any other forms of matter. Despite this lack of interaction, it's thought that when two WIMPs collide, they annihilate each other, in the process releasing other particles, including gamma-ray photons. One of the ways astronomers are trying to determine what dark matter is looking for regions of space where dark matter should be concentrated, such as the centres of galaxies, including our own Milky Way, and they've been doing that through astronomical observations for years in search of these specific gamma-ray emissions. This new study's lead author, Tomonori Totani from the University of Tokyo, believes he's finally detected the specific gamma rays predicted by the annihilation of theoretical dark matter particles. Tomonori and colleagues detected gamma rays with a photon energy of 20 gigaelectron volts. Now, that's an extremely large amount of energy, and they saw it extending in a halo-like structure towards the centre of the Milky Way galaxy. Tomonori says the gamma-ray emission component closely matches the shape expected for the Milky Way's dark matter halo. The observed energy spectrum, or range of gamma-ray emission intensities, matches the emission predicted from an annihilation of hypothetical WIMPs with an approximate mass about 500 times that of a proton. And the frequency of WIMP annihilation, estimated from the measured gamma-ray intensity, also falls within the range of theoretical predictions. Importantly, these gamma-ray measurements aren't easily explained by other, more common astronomical phenomena or gamma-ray emissions. The authors therefore consider this data a strong indication of gamma-ray emission from dark matter. Tomonori says if correct, it marks the very first time humanity has seen dark matter. And it turns out this means dark matter is indeed a new particle, one not included in the current standard model of particle physics, the foundation stone of science's understanding of the universe. If confirmed, it signifies a major development in astronomy and physics, one of the most important discoveries ever. While Tomonori is confident that his gamma-ray measurements are in fact detecting dark matter particles, his results still need to be verified through independent analyses by other astronomers. And even with this confirmation, scientists will still want additional proof that this halo-like radiation being observed is indeed the result of dark matter annihilation rather than originating from some other astronomical phenomena. Additional proof of WIMP collisions in other locations that harbour high concentrations of dark matter would bolster these initial results. Detecting the same energy gamma-ray emissions from, say, dwarf galaxies within the Milky Way halo would support Tomonori's analysis. And he says this could be achieved once more data is accumulated, and if so, it would prove even stronger evidence that some gamma rays originate from dark matter collisions. This is SpaceTime. Still to come, the European Space Agency's CHEOPS spacecraft about to reach another milestone, and a major disaster at the Baikonur Cosmodrome as the Soyuz MS-28 spacecraft blasts off for the International Space Station. All that and more still to come on SpaceTime. The European Space Agency's CHEOPS spacecraft's about to hit another milestone as it heads towards its 6th year of what was originally meant to be a 3.5-year mission. CHEOPS, the Characterizing Exoplanet Satellite, was launched back in December 2019 on a mission to determine the size of known exoplanets, that is, worlds orbiting stars other than the Sun. The probe is positioned in a 700-kilometre high sun-synchronous orbit and is equipped with a 30-centimetre optical telescope. The spacecraft's observations will estimate an exoplanet's mass, its density, and its composition, allowing better hypotheses of its likely formation. CHEOPS will measure the size of known transiting exoplanets orbiting bright and nearby stars, and it will also be searching for predicted transits of exoplanets previously discovered by way of radial velocity measurements. Now, the transit method involves monitoring a dip in starlight observed as an orbiting planet passes in front of its host star as seen from Earth, or at least in this case, as seen from CHEOPS. The radial velocity method involves monitoring how the gravitational pull of an orbiting planet causes a slight wobble in its host star. Now, that wobble can be detected through a slight red or blue shifting of the spectrum of light emitted by the star. In 2023, the CHEOPS mission was extended to 2026, allowing astronomers to widen their observation to search for exomoons, that is, moons orbiting planets orbiting alien stars. CHEOPS project scientist Kate Isaac says the probe's been especially focused on exoplanets in the Earth to Neptune size range. This report from ESA TV.
CHEOPS is a satellite in ESA's science programme. The acronym CHEOPS stands for Characterizing Exoplanet Satellite, and that is exactly what we do. We observe stars that are known to host exoplanets. So in that way we know where to point and when to point. And we'll measure the output of these stars and look for the transit of the planet across the disk of the star. So we'll look for the small changes in light that take place when a planet moves across the star. Our observations could take 6, 8, 10, 12 hours, and by measuring the dip we can determine the size of the planet. By combining the size of the planet with its mass, we're able to determine its mean density. By combining this with information that we have about the host star itself, we can start to say something very concrete about the composition of the planet, its internal structure, and so start to lead on to its structure, formation and evolution history. Very important information about planets beyond our own solar system.
And this is the first time this is done. I mean, you know where to look at, but you don't know exactly. I mean, this is the added value of CHEOPS.
The added value of CHEOPS is we're following up on known targets. So instead of missions such as Kepler, TESS and indeed Plato, ESA's future exoplanet mission, we know where to point. So we're able to make very efficient observations. We move and point towards a star when we know that the planet is going to transit. So instead of spending several months, maybe, pointing at a blank fraction of the sky, looking for the transits, monitoring very many thousands of stars and looking for small dips in their output, we're able to go quickly around the sky, maybe spend 10, 20, 30 hours on known stars, known bright stars, and to measure the sizes of their planets in that way.
You mentioned the dip, meaning that it will be something in front of the star or the sun, because it's solar systems you are looking at in a way.
Planetary systems. So what we're doing is we're looking at the planets as they orbit around their host star. So in the same way that the Earth goes around our star, our sun, other planets orbit their own host stars. And what we'll do is we will monitor these stars and we look for these dips. As the planet moves across the disk of the star, as seen by us from a large distance, we're able to determine the size of the planet from the small dip in the output of the star. So in the light that we measure from the star.
You will be able to tell us if there are Earth-like planets and life on this?
Be focusing on small planets, so Earth to Neptune size planets, and by combining the sizes, the very precise and accurate sizes that we get with measurements from CHEOPS, with measurements of mass that will be made from telescopes and observatories on Earth, we can get the density. Now, as you know, density is something that tells us about what the planet is made of. Something that has a high density, something like iron, is very much more compact. Whereas if something has a low density, it's more gassy. Earth is somewhere in between. And so by being able to work something out about the density, we're able to say something about whether the planet is Earth-like or whether it's more gassy instead.
And in that report from ESA TV, we heard from CHEOPS project scientist Kate Isaac from the European Space Agency. This is SpaceTime. Still to come, a major disaster at the Baikonur Cosmodrome, and later in the science report, a new study warns that people suffering from autism are far more likely to have suicide-related behaviours. All that and more still to come on SpaceTime. There's been a major disaster at the Baikonur Cosmodrome as a new crew launched into orbit bound for the International Space Station. The trio had launched on a 47-metre tall Soyuz 21A rocket from the Cosmodrome in the Central Asian Republic of Kazakhstan.
Sverchkov reporting that he and his crewmates, Chris Williams and Sergei Mikheyev, are ready for launch.
And the flight engineers through the S-arm of the descent module camera.
Everything is in good shape. The launch control reporting that the range at Baikonur is clear, the Soyuz rocket ready to begin its journey.
The complex is ready. Go for launch sequence.
Launch key inserted.
Go for launch sequence.
The launch key now has been inserted in the launch bunker, transitioning the launch sequence into its automatic mode. In about 30 seconds, onboard systems will be transitioned to onboard control. Sergei Sverchkov, the Soyuz commander, in the center seat, flanked to his left by Sergei Mikheyev, and to his right, NASA's Chris Williams. Williams and Mikheyev about to embark on their first journey into space. This is the second flight into space for Sverchkov, a Baikonur native.
We have nitrogen purging, 30 and 70.
The fuel lines and other elements of the rocket engines are being purged with nitrogen right now. That fireproofs them by removing vapors of fuel and oxidizer from the base of the launch pad. The skies have cleared nicely over the Baikonur Cosmodrome. Temperatures in the mid-40s Fahrenheit. The ground propellant feed in the process of being terminated to the rocket. The booster tanks now pressurized for flight.
Copy. I copy the report. Ground power disconnect.
The vehicle on internal power. The first umbilical now retracting.
First umbilical tower from booster. Ground propellant field termination.
Tower from booster. Ground propellant feed terminated.
The second umbilical now retracting. Standing by for engine sequence start. We have main engine ignition. Preliminary, intermediary.
Second umbilical tower.
T-minus 4 seconds. 3, 2, 1.
Turbopump at flight speed. Engines at maximum.
And liftoff. Holiday travel underway for the rocket ride to the International Space Station.
All onboard systems are nominal.
All onboard systems are nominal. Good first stage performance reported from the blockhouse in Baikonur.
Plus 30 seconds.
30 seconds into the flight, the Soyuz booster arcing out to the northeast from the Baikonur Cosmodrome. Good roll, pitch, and yaw program, good structural stability on the rocket. Engine chamber pressure is nominal.
On board.
Passing through the area of maximum dynamic pressure on the vehicle, max Q as it's called. Good first stage engine performance reported.
The vehicle is nominal. Everything's fine on board as well.
And we have confirmation of first stage separation. The strap-on boosters falling away nominally.
Stage separation is confirmed.
The Soyuz now operating on the power of its second stage engine.
We confirmed
The launch shroud encapsulating the Soyuz spacecraft has now been jettisoned. All is green from the blockhouse in Baikonur. Kudzverchkov reports he and his crewmates are in good shape, feeling great.
your pitch and roll are all nominal, and we, on our side, everything's fine on board. We're feeling good.
And we have second stage shutdown.
Second stage separation confirmed.
The third stage engine now propelling the Soyuz to its preliminary orbit, providing 67,000 pounds of thrust. This burn will continue until about the 8-minute 46-second mark, when it will shut down and the Soyuz will be placed into its preliminary orbit.
The vehicle is nominal. Copy. Everything's fine on board.
The 3 Expedition 73-74 crew members arrived safely at the space station. Their Soyuz MS-28 spacecraft flew on a 2-orbit fast rendezvous trajectory, docking onto the Nadir port of the orbiting outpost Razvet module just 3 hours and 11 minutes after launch. The Soyuz MS-28 crew are slated to remain on station for 8 months, returning to Earth in July 2026. However, while that mission proceeded smoothly, major drama was unfolding back on Earth at the Baikonur Cosmodrome. It appears the main service access platform at the Site 31 launch complex at Baikonur collapsed during the liftoff of the Soyuz mission. The mobile service tower was torn off by the exhaust plume of the Soyuz first stage, collapsing into the fire protection pit and destroying the service bridges and access gantries. The extent of the damage means Pad 31 is now unusable. This is the only launch facility at Baikonur, or for that matter in Russia, that can support manned Russian space missions. It means that for the first time in 60 years, Moscow doesn't have the ability to send people into space. It also means the upcoming launch of the Progress MS-33 cargo ship bound for the International Space Station, which was slated for December the 21st, has now been delayed indefinitely. Early estimates suggest the repairs and reconstruction could take up to 2 years to complete. There are no alternative launch facilities available, so Roscosmos will now need to look at modifying other Soyuz launch complexes, such as those at the Plesetsk Cosmodrome north of Moscow or the Novoskoshny Cosmodrome in Russia's Far East, or even maybe the unused Soyuz launch pad at the European Space Agency spaceport in Kourou, French Guiana. Although with the current ban by Europe on cooperation with Russia following the Kremlin's invasion of Ukraine, that may be difficult. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study warns that people suffering from autism are more likely to have suicide-related behaviours and psychological distress. The findings, reported in the journal Autism Research, shows that these behaviours are more likely, irrespective of previous traumatic experiences. The research shows that as many as 1 in 4 people on the autism spectrum have reported suicide attempts across their lifetime, and autistic people also have a higher likelihood of adverse life experiences. The study examined 424 autistic and 345 non-autistic adults, looking across 10 issues: education, employment, finances, social services, the criminal justice system, childhood victimization, adulthood victimization, domestic abuse, a lack of social support, and mental health. They found autistic people who experienced childhood victimization, something that happens in almost 100% of cases, were more likely to report mental health conditions later in life, conditions which impacted their daily life, as well as self-harm, such as cutting, suicide plans, and/or suicide attempts. Archaeologists claim the famous Easter Island statues of Rapa Nui were likely created by numerous independent groups rather than under the auspices of a single hierarchical organisation. The famous World Heritage listed statues were carved by Polynesian communities from the 13th century. The study's authors collected over 11,000 images, creating a three-dimensional model of the main Moai stone statue quarry, which included hundreds of moai preserved in various stages of completion. Their analysis, reported in the journal PLOS ONE, revealed 30 distinct centres of quarrying activity, which featured different carving techniques, and that, the authors say, suggests multiple independent work areas. They also found evidence for moai transport out of the quarry in many different directions, and the authors say this suggests that moai construction, much like the broader Rapa Nui society, was not organised by central management. The authors say the findings challenge the common assumption that this scale of monument production required a hierarchical organisation. A new study has found that a 3.4 million-year-old partial foot discovered in Ethiopia back in 2009 may have belonged to an ancient human relative named Australopithecus deiromeda, a more primitive species of the early hominid than the more famous Lucy, who was an Australopithecus afarensis. Previously, the species that this foot belonged to couldn't be identified because identification requires a bit more fossil evidence than just some foot bones. But the authors recently discovered more fossils in the same areas where the foot was found, including a jawbone, pelvis and skull fossils, and they belong to the earlier species, suggesting that the foot may also be from that same individual. A report in the journal Nature says an analysis of the enamel on the teeth found in the jawbone suggests that these early hominids ate leaves, fruits and nuts from trees, shrubs or herbs, and may have spent quite a lot of time actually living in trees. Well, to quote the immortal Dr. Sheldon Cooper, there is absolutely no scientific evidence to support clairvoyance of any kind, which means that fortune-telling is a fraud, the profession is a swindle, and its livelihood is dependent on the gullibility of stupid people. I say that in the prelude to this story about famed TV psychic Sylvia Browne. She gained infamy for widely inaccurate predictions to the families of missing children, and it appears she's gone viral yet again. But this time for the right reasons. Clips of Browne shared around social media are gaining popularity, mocking her as a grifter who said the wildest nonsense that she simply pulled out of thin air. Tim Mendham from Australian Skeptics says perhaps there is hope for some level of sanity and lucidity to triumph on the internet over psychic swindlers and deplorable grifters like Sylvia Browne.
Sylvia Browne was an American psychic, in quotes, who was famous for making predictions about people who've disappeared, where they would be found or not found, as the case may be. She was a fairly blunt woman. A grieving parent would come to her and say, I want to find my child, they've disappeared, where have they gone to? And she'd be blunt and say, nope, they're dead, or they're alive and they'll come back to you, etc. She was terrible at it, but she was good at presenting it and had confidence in it. She was very rich, she ended up being. Her statements about people who are dead were often proved wrong. Like there was a famous case where she was talking to a parent of a girl who disappeared, and she told the parent that, no, your child is dead, they're found in a river or something like that. And the parents were totally despairing, and one of them, the mother died, and then a few years later the daughter turned up. She had been kidnapped, one of those cases of someone kept in a room for a long time, and she had been kidnapped, she turned up. But of course the parents had been devastated by what Sylvia Browne had told them. And the reverse is also true. When she said, oh no, your child is living in another city, they've got married or something like that, and they got kids, and turned out they're dead, right? And they died shortly after they disappeared.
She sounds like she's a thoroughly evil person.
She is, and we can say all sorts of rude names for her, but we won't, because this is a family show. But she was notorious, and she played on her bluntness. People say, oh, she's not the usual psychic who's very nice to us. She's actually, very straightforward. She must know what she's talking about, because she's sort of such a glum, blunt sort of person. I think she would smile, and that would worry you, because she was a fairly extreme person with very extreme makeup. She had horrible nails. And a lot of people were very, very anti-Sylvia Browne. And once she died, which was a few years ago, a lot of stories would come out about how terrible it was. And apparently there's just been a bit of a...
She's dead.
Yeah, a bit of that. There's a lot of stories that just cropped up recently. It's become a bit of a viral thing again to raise the horribleness of Sylvia Browne and all the stories that she supposedly told people that were wrong, and they're calling her a grifter who, quote, made the wildest nonsense that she pulled out of thin air, and yet she became rich out of it.
It's a tale about the pestilence of psychic swindlers, isn't it?
Very much so, and this is sort of one of the things that skeptics get very involved about and very upset about is when they hear about psychics making predictions of things and taking advantage of what you call grief vampires, taking advantage of someone whose child or family member has died and they're trying to get in touch, or whose child or something has disappeared. And there's definitely psychics out there who rub their hands together and said, "Oh, money," and they will then take advantage of a grieving person as the lowest of low. And the psychics you think of in the cartoon version of a woman with a scarf wrapped around her head, looking like a gypsy woman, that sort of thing. It's far from the truth, and the psychics can be very, very dangerous in what they say to people. Then, even when they're supposedly trying to be nice and friendly and things, they can be very harmful, certainly financially, certainly wasting your time, and certainly emotionally too. It can be quite devastating, either by offering false hope or by giving false grief or unfounded grief. It becomes an unfunny topic that the skeptics get a bit annoyed about when they realise how much money and grief is involved in them.
That's Tim Mindham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.